Okay, we are on the last section, 1.2D. We're kind of starting in the middle with number 3. We're not going to do the tiles. So I am going to show you some weird or different outcomes for equations. Sometimes, no matter what you plug in for x, you can't find it. You can't make each side equal, or any number that you plug in for x would work. So let's do some examples together. So let's start to solve number 3. So when we try to get the variables to one side, the variables cancel out and you are left with -1 equals 1. And on no planet, anywhere, anytime, does -1 equal 1. So when you get an answer like this where your variables are canceled and they're not equal, what's left is not equal, that means that no matter what you plug in for x, you're not going to be able to get that equation to work. So your answer will be no solution. Number 4. This time, when you add 5x to each side, I have 10x minus 10 equals 10. Holy cow, there's a lot of 10s. So I'm going to add 10 to each side here. So I have 10x equals 20. I'm going to divide by 10, and x is 2. That means the only thing that you could plug into that equation to make it true or equal on both sides is 2. So this would be an example of an equation that had exactly one solution. Okay, so let's look at number 5. Alrighty, so if I distribute, which is the first thing on my to-do list, I have 4 times m, which is 4m, 4 times 3, which is -12, bring down my 10m, -6 times m is -6m, -6 times 2 is -12. If I combine these on this side, let me bring this down, I have 4m minus 12m. And let's just keep going. So if I have going to subtract 4m from each side to bring it to one side, this time I'm left with -12 equals -12. And yes, -12 is equal to 12, so that means that anything that you plug in for m is going to make this true. So your answer will be infinitely many solutions. Infinitely many solutions. All right, let's try number 6. 4 quantity x minus 4 equals 4x minus 16. So I have 4x minus 16 equals 4x minus 16. So once you learn to recognize these, you're going to see that you have exactly the same expression on either side of the equal sign. And if you don't need to go any farther, if you see that it's the same like this, you can just answer infinitely many solutions. All right, number 7. So we have 2x minus 5 equals 2 times x, which is 2x, and 2x minus 10. So you're going to start to recognize the pattern here. I have the same coefficient, or the number in front of x, but I have different constants. So let's see what happens. If I subtract 2x from both sides, my variables are canceled, and I have -5 equals -10. On no planet anywhere is -5 equal to -10, so this is a no solution. So you may start to see the pattern so that you don't have to work these all the way down. So I have 3x equals 3x minus 4. Well, let's see what happens here. If I subtract 3x, I have nothing. 0 equals -4. And on no planet, anywhere, anytime, is that true? So this is another one of those, no solution. Nothing will work. Number 9. All right, so let's distribute first before we do anything. So I'm going to copy this left part down. So I have 5 times 2 is 10. 5 times v is 5v. Okay, so I'm going to combine these. So 3v and 2v is 5v plus 5 equals 10 plus 5v. Well, we see these are the same, but we see our constants are different. So that's a definite pattern that we saw before. So let's just see what happens. If I subtract 5v, I have 5 equals 10. And again, no planet anywhere is 5, 10. So no solution. Number 10. You know, sometimes you notice the pattern sooner. Sometimes you just can't see it till you get to the end. And either way is okay. So I'm going to distribute that negative sign, bring down the 5. -1 times 4a is -4a. -1 times 8 is -8. So don't try to guess too soon. So, oh, look at what we have here. Exactly the same thing on either side of the equal sign. And in this case, that would mean that any number you plugged in would work. And I just want to show you, we recognize that right away, but I want to show you what this looks like if we solve it all the way down and we don't catch it. So I have 5 and -8 together, which is -4a minus 3. And here, it's -3 minus 4a. If I add 4a to each side, whoops, I have -3 equals -3, and they are equal. Okay? All right, 11. So I have 2x plus 8 over 2 equals x plus 4. So you may not see this right away, and we may have to get closer to solving. So to get rid of that 2, we're going to multiply everything by 2. So here, I'm left with 2x plus 8. And when I distribute, lo and behold, I have 2x plus 8. So we have same thing here as here. So our answer is infinitely many solutions. Okay, so let's take 1/3 quantity x minus 2 and set it equal to x over 3 minus 2/3. If I distribute this, you have to be really careful where you put the x. I have x over 3 minus 2/3 equals x over 3 minus 2/3. And again, same thing on either side of the equal sign is going to lead to an answer of infinitely many solutions. Oop, can't spell. Write that the right way. Things right. That means no matter what you plug in for x, you're going to have, it's going to be equal. Okay? All right, so one more thing I want to go over Let's go to number 13. So we're looking for a pattern, and it's helpful for you to memorize these patterns so that you don't have to go through the whole deal. Okay? So when you have an equation with one solution, you are going to have different coefficients and different constants. So let me show you. So I have 2x plus 1 equals 3x plus 4. Okay, so if I subtract 2x, I have 1 equals x plus 4. If I subtract 4, I have x is negative 3. So these are different, and then the constants are different. They can also be the same, and then the constants can also be the same, and your answer would be 0. If you have infinitely many solutions, then your constants are the same and your coefficients are the same. So you may not see it right away, but if you get somewhere like this, then you know that no matter what you plug in, it's going to work. So it's infinitely many solutions. So no solution would be the coefficients the same, constants different. We would have 3x plus 9 equals 3x plus 4. Because here's how it would go. So if I subtract 3x from both sides, I'm left with 9 equals 4. And you know, no planet anywhere does 9 equal 4. Okay? So let's just do a couple. You know what? No, that's all we're going to do. Okay? So let's say this. Try to, without solving all the way down, get to the infinite solution or the no solution. So if you don't catch it, that's fine, but try to save yourself some work. All right, that's it.